Actually, flat welding may look simple, but it has many different techniques. The four most commonly used are straight line, zigzag, step back, and circular weaving. So, which method is the most practical and the easiest? Without a doubt, it's the straight line method. For beginners, the very first lesson, Indian WeldMastar sharing. Flat welding practice is learning to weld straight and steady. Today, let's learn. We're using acidic electrodes, Model 4R. Keep the rod vertical on both sides, and when welding, just move straight forward. No extra movements are needed. For flat welding, current is very important. Remember, flat welding likes high current. With a 3.2 electrode on a 10mm plate, set the current between 130 to 140 amps. Don't go too fast. Weld slowly. Keep the arc pressed down firmly. If you want the slag to lift cleanly afterwards, you must hold the arc steady. With the heat focused on one point, the molten metal burns fully and forms properly. If your travel speed is even and your arc pressure is steady, the weld bead will come out very straight and flat. And the slag, it will naturally peel off by itself.
Why do beginners struggle with flat welding, often causing slag inclusion? When new welders do stick welding, the weld bead often doesn't build up properly and slag easily gets trapped. These are the problem. 1. Current too low. If the current is too small, the flux coating doesn't open up, the base metal isn't penetrated, and slag is trapped. 2. Arc length too high. If the arc is held too far from the plate, the arc isn't concentrated, making it difficult to fuse the metal, which leads to slag inclusion. Too high an arc also causes arc breaks. Correct arc length should be 1 to 2 millimeters above the weld pool. 3. Travel speed too fast. If the electrode moves too quickly, the bead becomes uneven, it doesn't tie into the base metal properly, and slag gets trapped. Slow equals thicker bead, fast equals thinner bead. 4. Electrode angle incorrect. Many beginners push the rod forward. This drives flux and slag to the front, trapping it inside the weld. Correct angles. Side-to-side angle, 90 degrees. Forward tilt, about 80 degrees backward, lean slightly back. Common flat welding techniques. 1. Straight line drag. Simple, no weaving, just pull straight. Produces a clean bead. 2. Zigzag/sawtooth motion. Faster, produces a flatter and smoother bead. Key rules. Keep current sufficient. Hold the arc low and steady, 1 to 2 millimeters. Maintain correct angle, backward 80 degrees. Control travel speed to avoid slag inclusions. Always direct the slag/flux backward away from the bead. Let's chip off the slag and take a look at the weld bead after welding. This is the weld formation. The bead is even in width and height. This is a flat weld. During flat welding, keep a steady forward motion and push the slag to the rear, so slag inclusion is less likely to occur. When finishing the weld, make sure the crater is filled properly. If you've learned something, please support and subscribe WeldMastar India for more information about welding. Thank you. Many beginner welders often encounter a problem when welding in flat positions with strong wind. It's easy to burn through or create big holes, which are difficult or impossible to repair. Today, I'm going to explain in detail how to handle this. In windy conditions like this, never drag the electrode continuously because this creates very high temperatures and makes burn through and collapse much more likely. I'll share 2 welding techniques for such situations. Keycap 1. Intermittent arc welding, safe but slow. This method involves pressing down just a little and consuming about half the electrode at a time. It's easy and safe to perform in windy conditions, but efficiency is low. Keycap 2. Fast welding method, 2-pass technique. First pass, dot and drag technique. Create the first droplet of molten pool, then quickly jump 3 to 5 millimeters to form the second droplet. Then jump another 3 to 5 millimeters for the third droplet. After forming the first droplet, quickly jump backward to form the second droplet. Then continue backward for the third. This avoids overheating, burn through, and collapse. Keep the arc low to quickly form the molten pool. Jump distances should be around 3 to 5 millimeters to leave gaps, preventing burn-through or collapse. Clean off flux residues thoroughly to reduce slag inclusions. Second pass, 2 forward, 1 back technique. This helps prevent burn-through and collapse. Move the electrode straight backward and forward in a linear motion to lower the temperature of the molten pool and fill it evenly, ensuring fullness. Ensure that the molten pool contains only clean, cool molten metal. Any leftover flux or slag can cause inclusions on the weld surface. Observation tips. Directly beneath the electrode, bright white areas are molten metal. Behind a molten pool, dark, dull areas indicate flux. Beginners should ensure the area under the electrode is clean molten metal to avoid inclusions. If there are small amounts of flux under the arc, dragging it around can create slag inclusions in the weld bead. Let's take a look at the inner layer of this weld. After we chip open the wall, you can see these small inverted triangle patterns. This technique is relatively fast and produces a neat, aesthetically pleasing weld. For those experienced welders who have mastered this, leave a like and subscribe WeldMastar India for more information about welding. For your support, thank you.